Good morning, grade 10. Today we will revise our trigonometric functions and we will learn how to verify trigonometric identities. Let's remember our rules for trigonometric functions. Sine x here equals 1 over cosec x, and cosine x equals 1 over sec x, and tan x equals 1 over cotan x. Also, we know that the reciprocal of cosec is sine. So cosec x equals 1 over sine, and sec x equals 1 over cosine, and cotan x equals 1 over tan. All these are reciprocals. And also we know that tan x equals sine x over cosine x, and cotan equals, it's the reciprocal of tan, equals cosine x over sine x. And we know that also our identities, sine power 2x plus cosine power 2x equals 1. The second rule is 1 plus tan power 2x equals sec power 2x, and 1 plus cotan power 2x equals cosec power 2x. These rules are very important, so you must know them well. Let's see the first example. Verify the identity or prove the following identity. We have here sec x times cotan x equals cosec x. We want to prove that this part or the left side here equal to the right side. So let's see our strategy to solve this type of questions. We must check which part is more complicated. So the more complicated side, I will start with it to reach to the simplest one. So of course here the left side is the complicating side. So I will start with the left side. So the left side here, sec x times cotan x. Let's remember sec x equals 1 over cosine. Very good. And cotan x equals cosine x over sine x. This is from the rules. So now we can, by simplifying a numerator by a denominator, so we're cancelling out the numerator with a denominator. So what is left now? 1 over sine x. And we know that 1 over sine x equals super reciprocal equals cosec x, which is equal to the right side. So I proved that the left side equal to the right side. Another example, cosec x times tan x equals sec x. As we did in the first example, we must start with the more complicating side. So the more complicating side here is the left side. So let's start with the left side. Cosec x tan x. As we know that cosec x equals 1 over sine, and tan x equals super sine over cosine. Who can tell me what I will do now? Excellent, I can hear you. So we can simplify the numerator with a denominator. So cross out a numerator with a denominator. So what is left now? 1 over cosine. So 1 over cosine x, which is equal to, very good, equal to sec x, which is equal to the right side here. Another example, prove that sine x tan x plus cosine x equals sec x. Who can tell me which part I will start with? Very good, I will start with the left side because it's more complicated. So start with the left side. Sine x tan x plus cosine x. I can replace tan x with the function sine over cosine. And I wrote sine x as it is and cosine x as it is. Next, I have here order of operations. I have addition and I have multiplication. What I will start with? Of course, I will start with multiplication first. So I will multiply the two parts together. So here sine x times sine x equals sine power 2x over cosine x plus cosine x as it is. Let's continue. From the previous slide, we reached till this step. So we have here two fractions because here cosine x is supposed to be cosine x over 1. So can we add two fractions unlike denominator? Of course not. We must reach to a like denominator. So we are going to make a cross multiplication here to make a common denominator, which is cosine x. So our common denominator now will be cosine x. So what did I do here? I made cross multiplication. So we can say that sine power 2x over cosine x plus cosine power 2x over cosine x. I made here cross multiplication to reach to a common denominator. So what next? I can add the two fractions now? Yes, because I have here same denominator. So sine power 2x plus cosine power 2x over cosine x. So who can tell me what can I see here in the numerators? Yes, our functions, our identity rule. So sine power 2x plus cosine power 2 equals, very good, I can hear you, equals 1. So all the part in the numerator equals 1 over cosine x. Who can tell me 1 over cosine x equals? Super, 1 over cosine x equals sec x. This is the reciprocal of cosine, which is sec x, which is equal to the right side here. So I already proved that all this complicated side equals to sec x. Another example, you can stop the video now and solve it, try solve it in extra paper by yourself, and let's go back to check the answer together. Okay, let's check the answer together. Of course, I will start here with the left side. So cosine x, cotan x plus sine x. Of course, cosine x, I wrote it as it is. Cotan x equals cosine over sine plus sine x as it is. Also here by multiplying, I will multiply these two parts together. So by multiplying, I can reach to cosine by cosine equals cosine power 2 over sine plus sine x. As we did in the previous question, we can say that here sine x is over 1, and we can't add two fractions unlike denominator, and we must reach to a like denominator, which is sine x. By cross multiplication, we can reach that 1 by cosine power 2 equals cosine power 2, and sine x by sine x equals sine power 2. And our common denominator is sine x, because here sine x times 1, because the denominator here equals 1. So sine x by 1 equals sine x. So what can you see now? I can see that in the numerator, cosine power 2x plus sine power 2x, which is our identity rule. Here, cosine power 2 plus sine power 2 over sine x. Cosine power 2 plus sine power 2 equals, super, equals 1. 1 over sine x, we know that 1 over sine x equals, excellent, equals cosec x, which is our right side here. Another example, here we start with this side because it's the more complicating side. We can say that we have here a common factor, which is cosine x. So we can say that take cosine x as a common factor. I wrote here the left side as it is, and I can see that we have cosine x common between the two terms here. So I took cosine x as a common factor. So what will be left? I will write it between brackets. Here, cosine divide cosine equals 1. And cosine divide this part equals sine power 2 x. So what next? I can say that this is an identity rule, because we know that sine power 2 plus cosine power 2 equals 1. So we can say that 1 minus sine power 2 equals cosine power 2. So cosine x, I will write it as it is. Cosine x here, I will write it as it is. And we know that all what is inside the bracket here equals cosine power 2x. It's from our identity rules. So cosine x times cosine power 2x, same base. So we will add the powers. The power here is 2, the power here is 1. So will be cosine power 3x, which is equal to the right side here. Another example. It's the same like the previous one. Also here we have sine x minus sine x times cosine power 2x. We want to prove that all this side equals sine power 3x. So we can say that we have here, I can hear you, very good. We have here sine x and we have here sine x. So we can take sine x as a common factor. Here, sine x as a common factor. So I will open bracket. What is left here after dividing? 1 minus what is left here after dividing by sine x? Cosine power 2x. Who can tell me what next? Excellent. What is inside the bracket here equals to sine power 2x. It's from our identity rule. So sine x times sine power 2x. Here, same base with the powers. So I will add the powers together. Here, our power here is 2, and here power is 1. So the answer will be sine power 3x, which is equal to the right side here. Another example. Here we have the left side equal to the right side. So let's start with the left side. Okay, who can tell me what did I do here? Very good. I separate the term on the left into two terms. I wrote here the left side as it is, and I can say that this denominator is common for both terms, for 1 and for sine theta. So I wrote here 1 over cosine theta plus sine theta over cosine theta. I distribute the denominator here among the terms. Okay, so it's more easy now. So 1 over cosine means, very good, means sec x . 1 over cosine here equals sec x. And sine over cosine equals, very good, tan x, which is equal to the right side. So it's very easy. It's only by distributing or separating our terms here on the denominator. So I can say that this part equals sec and this part equals tan. Let's see. Inshallah, our homework will be on LMS. Watch the video very well and answer your homework, and I'm waiting for your answers. Thanks, grade 10, and have a nice day.